Okay, I talked about square roots in the last video, the spiral of Archimedes, and the fact that the square root of 5, numbers like it, square root of 3, square root of 7, square root of 6, they're real. Now, there are some technical details about how to work with roots, and I think mostly I'd like to discuss those as they come up. But let me give you a couple examples of what do I mean technical details about how to work with roots. Well, here's one. Just consider the following. Square root of 9 times the square root of 16. Wait, let me use an easier example here. The square root of 4. Now, no doubt the square root of 9 is 3. The square root of 4 is 2. And 3 times 2 is 6. Okay, no problems. Just observe. Square root of 9 times 4. What's 9 times 4? 36. What's the square root of 36? 6. What am I getting at here? Without doing a formal proof, which is no big deal, but without doing a formal proof, we have the following. The square root of a times the square root of b is equal to the square root of a times b. This is nice. This we will use from time to time. Let me show you a classic way that you're shown to use this. I'm always thinking about how important is this, and what I'm about to show you, maybe it isn't sort of mathematically that important, but to use a lot. Therefore, it is important. And I'm sure you've seen this before, but if not, fine. Okay. Let's say we had the square root of 20. Now, the square root of 20 is the square root of 20. That's what it is. In other words, remember, if it isn't nice, if it isn't the square root of a perfect square, it is what it is. So the square root of 20 is the square root of 20. Nonetheless, that's not how most people would write it. That's correct. You can write it like that. I mean, what you're looking at is a correct, absolutely correct number. It's well defined, so on and so forth. However, just consider doing the following. You look at 20 and you think, 20. Oh, yeah, it's 4 times 5. And now I can use that property. Square root of 4 is 2. So the square root of 20 is the same thing as 2 times the square root of 5. Now, it's not like I got an answer. I didn't answer the square root of 20. The square root of 20 is the square root of 20. I didn't, like I said, I didn't answer it. And something you'll see or hear a lot is people will say that, well, let me do another one and I'll tell you what people say. And it's really not right what people say, even though what I've done here is correct. Let's say we had, I don't know. How about the square root of 18? And I'm picking numbers very carefully here so that I can do this sort of thing. But 18 is 9 times 2. And that's the square root of 9 times the square root of 2, and that's the 3 times the square root of 2. So what you will hear people say, they may say, for example, the square root of 18 simplifies to this. Now, that's actually not simplifying, and I know that's what people say, but stop and think about it for a minute. Here I have the square root of a number. So this is the square root of a number. This is the square root of a number times a number. This is actually more complicated than this. It's not simplified, but oh boy, I know that's how people refer to it, and that's how people talk about it. So I won't myself, but I get it. So if you were to take, say, an SAT or some kind of standardized test, they might ask you to simplify the square root of 18, and I know that's what they want you to give as an answer. I suppose it's simplified in the sense the numbers are smaller. And you could say lots of things like I extracted a root of one of the factors of 18, but that really doesn't make matters easier. Now, if you have a modern calculator, and there's a way you can tell you have a modern calculator. If you have a calculator and it's been programmed within the last 10 years, you can tell, because just type in something like the square root of 50. If it's an old style calculator, it'll give you some decimal approximation, 7 point, I don't know, whatever, because sometimes 7 is 49, so it'd be a little bit more than 7. But if you have a newer style calculator, this right here, this will say 5 times the square root of 2, because what it's doing is it's saying the square root of 50 is the square root of 25 times 2, and the square root of 25 times the square root of 2, the square root of 25 is 5, and so that's where that comes from. Or if you type in the square root of 8, it'll say 2 square roots of 2, because what is the calculator doing? It's saying, well, the square root of 8 is the square root of 2 times 4, which is the square root of 2 times the square root of 4. Square root of 4 is 2, so 2 times square root of 2. How is this useful? A lot of times it's not, but sometimes it is. And here's just one classic case in which it is useful. Suppose we have the square root of 8 divided by 6. I don't want to write down a wrong thing right now, even to show you a wrong thing. It's too dangerous, so I'll just say the wrong thing. Suppose you tried canceling, 2 goes in 8, 4 times 2 goes in 6, 3 times. Don't do that. That's wrong. You can't do that. The 8 is trapped inside the square root. However, we just saw that this is 2 times the square root of 2 divided by 6. Now that is simple regular multiplication. And then, 2 goes in there once and 2 goes in there 3 times. So this is the square root of 2 over 3. Now, this is equal to this. This is simpler than this. The structure is the same. It's the square root of a number divided by a number, square root of a number divided by a number, but the numbers here are easier. So this is preferable right here. Hey, one quick comment here, and it's a classic place where this comes up. Classic place where this comes up is in trigonometry. And maybe you've taken some trigonometry before, maybe you haven't. But let me just say that this number, that particular number comes up a lot when dealing with trigonometry in any setting. That could be trigonometry within a calculus setting or trigonometry within a trigonometry course setting. But this particular number right here comes up a lot. I'm not saying why. I'll probably show you, but not right now. But it does. Nonetheless, not everybody writes it that way. A lot of people do the following. They multiply this top and bottom by the square root of 2. And wow, if you haven't done this before, you really should ask, why would anybody do such a thing? So this is just out of the blue. It's like a rabbit out of a hat. Look, I'm multiplying top and bottom by the same thing. Now, anything divided by itself is 1, so I am allowed to do this. I just haven't said why or if anybody would want to. And this is equal to the square root of 2 over, what's the square root of 2 times the square root of 2? Well, that's the square root of 2 squared. And we talked about this already. This is 2. On the other hand, I could say the square root of 2 squared is the square root of 2 times the square root of 2. And by that property I just mentioned, this is the square root of 2 times 2, which is the square root of 4, which is 2. So no matter how you slice it, that's 2. So, for example, if you take your modern calculator, if it is a modern calculator, it doesn't have to be an expensive one. Like one of my favorites, I haven't really looked into calculators recently because more and more I just use online calculating devices. But my favorite for a long time was the Casio FX115 or 300, and the ES mattered. There was an MS model, which is older. But that's not the only one. I mean, there's all kinds of them. But this was like a $10 calculator, and it's pretty darn sophisticated. $10, it's amazing. But if you typed in 1 divided by the square root of 2, that's what it would put on the screen. And it does that because it knows, for example, for a large percentage of textbooks and standardized tests, this is the form in which they write this. There are some texts that write it like this. Matter of fact, I remember, I hope I remember correctly, but I remember in my Calc 1, when I took the first semester of calculus, and this was written in an answer in the back of the book, and I couldn't wait. I went in and talked to my professor and I said, the book's got an error. Impress him. I had found an error in the book. And I remember he looked at this and he said, what? And I said, oh, look, it's wrong. It's wrong. And he said, it is? And I said, come on, quit kidding around. You can't write it like that. He said, you can't? I said, everybody knows you can't write a square in a denominator. And he said, what do you mean? And I said, well, you're supposed to do this. And he said, you are? And I said, come on, you're driving me crazy. Why what, you know what I'm talking about? And then he said, why is this any better than this? And I said, well, because there's no square root in the denominator. And he said, but you didn't get rid of the square root. It's now up in the numerator. And why is that better? And I went, because everybody told me that's better. And then I realized it's not actually better. It's just a different way to write it. And in fact, you may have heard that you're not supposed to have a square root in the denominator. And that's a bogus rule, but it's a bogus rule made up with a good intention. And the intention is to get you to practice these rules of roots. So just like the rules of exponents, you have to practice the rules of roots. Now, I want you to just watch one example of something that fails. So let's take a look at this. Square root of 9 plus the square root of 16. Now, no doubt about it, 9 plus 16 is 25. So I don't think anybody would doubt that that's true. And what's the square root of 25? 5. Okay, so that's definitely the answer. I'm going to do something right now which is wrong. I am going to do something right now which is wrong, but it is a classic student error. So I'm going to do something right now which is wrong. Don't do this. If I did, this is the square root of 9 plus the square root of 16, and the square root of 9 is 3, and the square root of 16 is 4, and that's 7. So this is false. So what this means is the following. I already established, I should erase that. I don't like having that completely wrong, a classic mistake on the board. This is true. However, you cannot do a similar thing with addition. Like this. You can't do it because it doesn't work. Not because I'm making some arbitrary rule up. But you saw a minute ago that example showed you that it just doesn't work. It doesn't work. Hey, again, if I did multiplication, and I did it separately, square root of 9 is 3, square root of 16 is 4, and that's 12. If I multiply these here, 9 times 16, which I don't walk around knowing, that's 90 plus, hey, wait a second, did I just do this right? What's the square root of 9? 3. Square root of 16 is 4. 4 times 3 is 12. What's 9 times 16? Well, that would be 90 plus 54 is 144. So that would be the square root of 144, and lo and behold, 12 times 12 is 144. So yes, the square root of 144 is 12, so all is good with the world. You also can do this. I won't bother demonstrating this like I did with the multiplication, but the square root of a divided by b is equal to the square root of a divided by the square root of b. Oh, will we be using this? You bet. Will we be using this property? Absolutely. Are these two things you want to know? Absolutely. You really do want to know that. And I'll just put a minus sign down here to indicate that you can't do it with addition and subtraction. So one way to put this is we say that roots respect multiplication and division, but not addition and subtraction. And it's just something that we're going to use as we go along, and we'll use on a fairly regular basis. I don't pre-plan out when I'm going to use it. I use it when I need to use it. I don't want to discuss it in this video. This is a fairly short video here. But we're definitely going to have to discuss what on earth, if anything, that means. And I'll save that for a separate video. So for now, till the next video, I haven't used as any examples the square root of a negative number, and I did that on purpose. And so in the next video, I think we'll discuss that. But one last thing for this video, and this will not finish this particular topic, but suppose we have something that looks like this. I think that our textbook here. Let me get the section this is out of the textbook here. 8.6. So this is from this particular type of equation right here is 8.6 radical equation. And how do you solve it? Well, let's take a look at this just for a second. You should always feel free just to contemplate. You don't have to immediately dive in and solve the question within 0.2 seconds. You're allowed to look at an equation and just think about it or ruminate over it. When I look at this, look, it's no fair. I've already solved 10,000 of these or 50. I don't even thousands, tens of thousands probably. So it's unfair. I already know where this is going. I already know this type. That's not fair. But it was the first time that I ever saw this. I wouldn't know what to do at first. I wouldn't know. But I tell you what, I would look at that and I would be bothered. I would be bugged, irritated, annoyed by this square root. It's bothering me. It's irritating me. It's bugging me. How can I get rid of it? Square both sides. So let's square both sides. And if I square both sides, I should probably say this once. If this is equal to this, they're the same thing. So what I'm really doing is I'm multiplying both sides by the same thing. But it's just a heck of a lot easier to say square both sides. Well, not is it easier, but it is equivalent to what I just said a second ago. So this is 3x minus 1 equals 49. Piece of cake, no problem. Let's add 1 to both sides. And okay, so this particular equation here turned out to be pretty easy. But they're not all going to be that easy. And as a matter of fact, I want to skip 8.6 for now. Once we do chapter 9, we're going to come back. So we are absolutely 100% going to do section 8.6, radical equations. Absolutely. But I think we're going to skip it right now. That first one I did fine. That was pretty easy. But they're not all that easy. And it would be really good if we had, not really good, but it would be mandatory that we have a skill from chapter 9. So for the time being, skip 8.6. In the next video, I'm going to talk about what on earth does the square root of a negative number mean. Then we'll move on ahead to chapter 9, and then we'll come back to 8.6 and pick that up. Okay, so properties of roots. Hey, look, this stuff has to be practiced. So there are hundreds and hundreds of problems in the book. You know, maybe untold numbers of problems. You need to practice these problems. So please make sure you practice them. I wish, you know, what if I could get, I'll give you $5,000 if you practice. That would probably work, but I'm not going to. So you're on your own recognizance that you practice these problems. Okay.